Hello everyone, my name is Marco Penón and I am presenting today alongside Lautaro Guiglioni.
Hi everyone.
We are electronics engineering students at the Nacional-Facultad University, Paraná Regional Faculty. Our presentation is titled Environmental Impact of Textile Waste, Implementing a Biodegradable Solution and Material for Sustainable Fashion. Today we will discuss our research, which aims to explore bacterial cellulose as a sustainable alternative to reduce the environmental footprint of the textile industry.
To begin, let us consider the context of the problem. So the textile industry is one of the most polluting sectors globally, and it faces significant environmental challenge. This includes excessive water consumption. So textile production processes are water intensive, with some garments requiring up to 20,000 liters of water. Chemical contamination, dangerous chemical uses and dyes and finishes process contribute to environmental degradation. And non-biodegradable waste, the widespread use of synthetic fibers coupled with fast fashion trends generates large amount of textile waste that often ends up in landfill. These challenges are exacerbated by the fast fashion model, with faster rapid production and consumption, resulting in short-lived products.
To address these issues, the textile industry must align itself with global sustainability frameworks, specifically the United Nations Sustainable Development Goal 12, which promotes responsible consumption and production patterns. As part of this effort, we propose the use of bacterial cellulose as a sustainable alternative that is a biodegradable material, like a potential solution to reduce the environmental impact of textile production.
The main objectives of this project are three: to assess the environmental impact of the textile industry, to propose bacterial cellulose as a sustainable alternative to conventional textile, and to explore ways to reduce the environmental footprint of textile production by promoting a circular economy.
Before we delve into the specifics, let me provide an overview of our presentation. First, we will explore the problem of textile pollution and its impact on the environment. Next, we will discuss the improvement of the textile industry, focusing on bacterial cellulose as a sustainable alternative. Following that, we'll cover the composition and harvesting process of bacterial cellulose. And finally, we will present an analysis of the advantage and feasibility of using bacterial cellulose in textile production.
The impact of this project is significant. By introducing bacterial cellulose into textile production, we aim to reduce production costs in long term by using renewable resources, decrease textile waste and pollution by promoting biodegradable materials, encourage sustainable and ethical fashion practices by shifting away from synthetic fibers, and advance the application of biotechnology in industrial production, demonstrating its potential for large scale.
To introduce the problem of textile production in the world, first, we need to know that the environmental impact of the textile industry is quite significant. The main problems include water consumption. It is large quantities of water are required for textile processing, specifically in dyeing and finishing. Also, chemical pollution. Hazardous chemicals used during production can contaminate water source and soil. And finally, textile waste. Fast fashion contributes to the disposal of millions of tons of textile each year, exacerbating waste and landfill problems. These factors place considerable strain on natural resources and ecosystems, underlining the urgency of finding more sustainable production methods.
To address these issues, the textile industry needs to adopt a transition strategy towards more sustainable raw material and processes. Specifically, we propose the following. First, sustainable raw materials. So the use of material cellulose, which is biodegradable and less resource intensive than traditional textile, and new production methods. So innovation that promotes more sustainable and ethical manufacturing practices, reducing environmental harm, and supporting long-term sustainability.
To introduce the material composition and harvesting process of bacterial cellulose, we need to know first that bacterial cellulose is a natural polymer produced by the bacteria Gluconacetobacter cellulose through a fermentation process. This material offers a range of benefits, like high purity, or like plant-based cellulose. Bacterial cellulose doesn't contain impurities such as lignin or hemicellulose. Also, excellent mechanical properties because its strength and flexibility make it suitable candidate for textile applications.
The harvesting process involves the cultivation of bacteria in a nutrient-rich medium, where they synthesize cellulose fibers that accumulate at the air-liquid interface. After this, the bacterial cellulose undergoes purification and further processing to prepare it for use in textiles. This process can also incorporate natural dyes and eco-friendly additives to enhance the material's properties for textile production.
To talk about the advantage and feasibility of this idea, we need to introduce the use of bacterial cellulose and its advantage in the market. It is a renewable resource that can be produced using low-cost materials. Also, the production process is environmentally friendly, generating less waste compared to conventional textile manufacturing. And finally, the material has superior mechanical properties, making it ideal for various applications in the textile industry.
Nevertheless, the feasibility of large-scale adoption faces several challenges. First, higher production costs. So bacterial cellulose production requires specialized method that increases the overall cost compared to synthetic fibers. And market acceptance. The fast fashion industry relies on cheap, mass-produced textile. Shifting to more sustainable materials such as bacterial cellulose will require overcoming resistance from both manufacturers and consumers. Despite this challenge, with continued research and investment, the viability of material can be improved, making it a promising alternative for sustainable textile production.
In conclusion, bacterial cellulose presents a viable solution to many of the environmental challenges faced by the textile industry. Its biodegradability, renewability, and eco-friendly production process align with global sustainability goals, particularly SDG 12. While challenges such as higher production costs and market acceptance remain, further research and development could make bacterial cellulose a greater alternative to conventional textiles. By incorporating this material into textile production, the industry can significantly reduce its environmental impact and promote sustainability and innovation. So, thanks for your attention and see you.
Goodbye.